Welcome to Errant Biomes tutorial. In the first part of this tutorial, we will initialize our world and we'll create some basic biomes and species. We'll also use landscape weight maps together with some custom logic to control where the foliage is spawned. Let's start by creating a new level. We can quickly initialize it using the environment light mixer. Now, let's create a landscape. It's recommended to enable edit layers, as this allows the biomes tool to adjust landscape using its own layer. It removes the risk of the tool overriding the manually sculpted parts. We'll create a 2 by 2 kilometer landscape. We'll be using a material with several weight maps, so let's initialize them first. Okay, now we'll add edit layers for the biome tool and manual sculpting. The important part is to lock the biomes layer to prevent your edits from being overwritten by the generated content. If we now try to edit that layer manually, we get a warning. Okay, so I made my landscape and I used 3 weight maps to paint it. Let's enter the biomes mode and initialize it. Select landscape and type the name of the edit layer that the biomes tool is supposed to edit. Now we are ready to create some biomes, sub-biomes, and species. I'll name the first biome Mountains, and I'll set its visualization color to blue. If we now enter the biome painting tool, we can see that the whole landscape is covered in our new biome. If we had multiple biomes, we could paint them in this tool. Let's add a sub-biome called Forest. And in that sub-biome, we'll create a species for trees. We can choose one of the templates to initialize our new species. That new species uses some blockout 3D models, which we will replace with detailed models later on. The first thing we will do is to adjust the spacing of the spawned trees. Setting this value to 500 means that 2 neighboring trees will be about 5 meters away from each other. We're now ready to generate the foliage. But first, let's select a smaller region of the map for regeneration. This will make regeneration faster. Okay, let's run the generation. The spacing of the trees clearly needs some tweaking. I will toggle the auto generation, which will start generation after every change I make to the species. Let's add a new sub-biome and species for the rocky regions. Each of our sub-biomes will contain just 1 species for now. We'll be adding more over time. We will use the big rocks template this time. Regenerating, and here they are. Currently, all of the placement is random and only affected by noise, but we will change that in a minute. I'll add a 3rd sub-biome and species for the grasslands and grass. We'll use the grass template this time. Okay, and the grass is spawned. It's using runtime generation, which means that instances of the grass are generated on the fly and spawned dynamically around the camera. It's because the density of the instances is very high, and it would take gigabytes of memory and disk space to store the transforms. The Biomes tool automatically enabled runtime generation for us, but we may alter this setting. Let's make the grass more interesting by adding some flowers. It seems there are too many flowers compared to the grass clumps, which made the grass appear sparse. We can adjust that proportion using the acid probability. The grass is still too sparse. To fix that, we'll take a look at the growth material mask. It is a crucial part of a species setup. This is where you can define custom logic for where and how a species should spawn. As we initialized our grass from a template, it uses noise in its growth mask. For a test, let's replace the noise with a constant value of 1. This will make the grass spawn uniformly within its sub-biome. Okay, the density went up. This means that our noise function is affecting how densely the grass spawns. It's time we did something interesting with the grass's placement. Firstly, we'll make it grow only in the regions covered by the grass landscape weight map. Errant Biomes tool gives us an easy way to access the weight map. We need to add a new material parameter, use the landscape weight map, and give it the name of the landscape weight map we want to read. In this case, it is grass. We also need to give it a name under which it will be accessible in the growth material. The name is arbitrary. We can go with weightmap_grass. Now we can access that weight map in the growth material. We need to create a texture sample parameter 2D and name it weightmap_grass, as that's how we named our parameter. We'll set a fallback texture to black. It means that it will return 0 if the grass weight map is missing. In the graph, I used a conditional node if to return something only when the weight map value is larger than 0.5. Otherwise it returns 0. I did that to make sure we don't have any straight grass instances in the dirt regions. I also multiplied the output value by 2 to make sure we spawn grass at maximal density. The saturate node at the end ensures that the result is clamped to the range of 0 and 1. Okay, we can now clearly see that the grass follows the patterns of crevices and isn't spawned on the rocky or sand weight maps. Here is a view with the trees being hidden. Using a weight map is a very powerful way of defining species placement. Combined with other inputs and noise, it allows for achieving very natural looking results. Let's restore the noise we had in the growth material and combine it with the weight map influence. The next thing we can do is to make the trees spawn where the grass species is. This is what we call an interspecies dependency. To achieve that, we need to enter the tree's species and add a new material parameter. The type is species. Now we select the species we want to depend on. It's our grass. And we'll give it the parameter and name. We can go with grass_growth. We then enter the growth material and add a texture parameter. Name it grass_growth. And here they are. The trees now follow the same pattern as the grass, with gaps created by crevices, sand and rocks. And we recombine that pattern with the noise. Okay, it's time to make our biome fill the whole landscape. We select all the tiles and click Regenerate. It doesn't look impressive yet, but we can see some patterns emerging. The use of procedural generation allows us to quickly add or replace the 3D models we are using. Let's swap our blockout meshes with the detailed models. That's it for this tutorial. If you liked it, please subscribe to our channel and visit our website errantphoton.com.